Hello everyone, welcome to the Skill Talk. In the last few Skill Talk videos, we have discussed some very important vibration concepts. We understood phase, and we also understood that how vibration signals can add together and cancel each other. We also saw that how amplitudes and frequencies interact, and how this affects both the time waveforms and the spectrums. So now that we understand those fundamentals, we are ready to explore another very common vibration phenomena in industrial machines. So in many plants, you may hear a strange sound from the machine, or you can say the humming sound from the machine. The sound becomes sometimes loud, then it will become soft, then loud again. So sometimes the cycle may the cycle of these between loud and soft can be 10 seconds, 1 second, or maybe more than 10 seconds. It depends. And sometimes it may happen very fast, let's say every second, or every it's continuously going up and down. So this sound may feel like a droning or a troubling sound, vibration you can say. So while collecting the vibration data, you may also notice that the peak in the spectrum rise and fall periodically. Let's say if you choose the option in your vibration analyzer for a continuous monitoring option, so you can see that continuously the peak in the spectrum rise and falls, right? What is the cause of this? So normally this phenomena is known as the beating. So beating occurs when two vibration signals with very similar frequency interact with each other, right? So when two frequencies are very close, sometimes what happen, they add together, sometimes they cancel together, right? So because of this, you will be seeing that the vibration is going high, low, and high again, right? So this repeating vibration in the amplitude, it produces the pulsating sound that we hear when we go near to such machines. So now let's imagine that one machine is running at the 25 hertz speed. So that is approximately 1500 rpm, which is that very common for industrial motors. What will happen that in 1 second, if I will calculate this time waveform, it will contain the 25 cycles. How it will contain the 25 cycles, we already discussed. Just 1500 rpm divide by 60, so you will be getting the frequency is nothing like the number of cycles in 1 second. So you will be getting 25 cycles. The sound in such machine, the normal machine, the sound will be very steady, or you can say the vibration will be almost same. So the amplitude will remain almost constant. So the vibration waveform is very simple and very stable. So now let's say that let's imagine a second same similar type of a machine that is running at same speed of 25 hertz. If the two vibration signals are perfectly in phase, let's say pump A and pump B both are running at exactly 25 hertz. So what will happen, that if the both the signals are in phase, so the waves, both the time waveform will add together, right? So what will be the result? The amplitude will be twice. Let's say the one pump vibration is 2 mm, another is 2 mm, so total amplitude you will be seeing there will be the 4. But the frequency will be remaining the same, because both of the machines are operating at the same speed or same frequency. So in that case, what we will see, that the sound become louder, but the frequency will not change, of course, because the speed is same. So now if we will imagine the another two signals, the same similar machines, but instead of in phase, now assume that the both of the signals are out of phase. That means 180-degree out of phase. So now what that means, that when one signal is moving up, the another signal is moving down. So overall the result will be that they will almost cancel each other. So what will be the result? So in this case, the amplitude will not be high or loud. It will, in this case, the amplitude will be either very small, or you can say zero, or you can say close to zero. So in theory, normally the waveform could become a flat line. So although in a real machines, some vibration will always remain. So that's why you can assume that it will be somewhere around close to zero. So this is the, the theoretical one kind of example that we have taken by assuming different situations. Now let's come to the realistic situation on field situation. Now let's say that suppose two machines are running, one is running at 25 hertz and another one is running at the 24 hertz. So these speeds, you know, that are very close to each other. So as the time passes, what will happen that these two signals will continuously move, right? It's not that always the signals will be at stable or at similar location. What happened that let's say there is signal A from machine pump A and signal B from pump B. So these signals always travel, so what will happen now, sometimes these signals will come in phase, sometimes it will be out of phase, then again in phase. So this cycle continues, right? So because of this, what will happen that the vibration amplitude will increase when they will be in phase and decrease when they will be out of phase, right? So again the same phenomena continues, increase again, decrease again, increase again, decrease again. So this repeating change in the amplitude, this phenomena is known as the beating. So instead of in this case, what happened that instead of hearing a constant tone, or you can say either I'm having a very high vibration or low vibration, what will be happening here, we will be getting a pulsating sound, or and also you can say the pulsating vibration. So for example, we will continue with the same example, the 25 hertz and 24 hertz, two signals. So what is the difference between them is 1 hertz. So the vibration level will be rising and falling every 1 second. So this is known as the beat frequency or pulsating frequency. So now why this vibration will be rise and fall every 1 second. So there is a simple calculation here. Let's say what is the difference between these two frequencies, 25 minus 24 is 1 hertz. So what is the beat frequency here is 1 hertz. So when I will calculate this beat frequency of 1 hertz into the seconds, or you can say the period. So what is the formula for the period? Period is equals to 1 by frequency. So 1 by 1, it will be 1 second. So what will happen here, the amplitude cycle here will be every 1 second. So every 1 second we will be seeing the pulsating sounds, right? So now if I will take some few more examples. Let's assume now one machine, pump A is running with the same 25 hertz and pump B now running at 24.5 hertz. So in that case, what will happen now, the beating frequency will be 0.5, right? So in that case, what will happen, when I will calculate the period, it will come now 1 divided by 0.5, that will 2 seconds. So in this case, you will be seeing the vibration grows and fades every 2 seconds. In the similar way, as I come more closer, let's say pump A and pump B are running very, very close to each other. Let's say 25 hertz and another one is for 24.9 hertz. Now the difference is far less, that is 0.1 hertz. So now what will be the beat frequency? 1 divided by 0.1, that will be the 10 seconds. So the vibration grows and fades will be every 10 seconds, right? I hope the concept will be very, very clear. So now the beating, how this beating will appear. So beating will appear in the two ways. In the time waveform, if you want to see in the time waveform, the waveform will be growing and shrink periodically, right? So let's say if your beating frequency is 10 seconds, so in every 10 seconds you will be seeing that waveform is going up down, right? So the envelope will be expands and collapse as the signal add and cancel each other. If the same thing, if you want to see in the spectrum, so in the spectrum sometimes you will be seeing the peaks rise and fall. Why I mentioned here sometimes, because if let's say the frequency resolution is not high enough, let's say, because once you are going for the data collection, you will be always feeding the details. Let's say you want to collect the data, what will be the f max and what will be your LOR. So let's say that your f max is 500 hertz and LOR is let's say 800. So definitely if the frequency the beating frequency is let's say 0.1 hertz, so definitely you will not able to catch that. What will happen now, these two frequencies, that is one is at 25 hertz, another one is at 24.9, they will overlap, right? You will be seeing as a overlap. So what you will seeing that the continuous, the spectrum, the amplitude is going up down continuously, right? Or it may appear as a one peak but with the changing amplitude. So this is often a strong indication of the beating. So if you will improve the resolution, then definitely let's say you have increased the LOR. Instead of 1600, if you choose 3200 or 6400, then definitely if your the the resolution is less than zero point 0.1 hertz, then definitely you can see two separate frequencies instead of this one frequency, right? So this is how the strong indication of the baiting. This is how baiting is. So how baiting can create, normally what happens that how baiting can be dangerous, so how baiting can be dangerous because it can create the large vibration variations. So for example, that two machines are there, pump A and pump B same. So what is happening now, in every 1 second, let's say the vibration is traveling from 5, minimum 5 up to maximum 10. So what will happen that over a period of time, definitely it can be a very destructive to your machine. So now the question will arise that how we can correct this beating. So normally there are two ways. One is definitely the controlling the speed. So we have to go through, let's say if there is a very similar application and two pumps are there that should run at very exactly same frequency, then you should see that what's the reason that why these pumps are, or you can say fans, whatever the application is, why they are having a slightly difference of, let's say, zero point 0.1 hertz, or maybe why there is a difference between that. Is there any problem in the speed controller adjustments or any load variations is there? So you will be checking the possible reasons for that, right? So another thing is this, that how you can avoid this phenomena is to reduce the vibration transmissions, because mostly this thing happen when especially that two machines are very nearby and especially mounted in the having the similar bases. So in this case what will happen, what you can do, you can improve the foundation isolation, or you can reduce the structural transmission path, or you can install the isolators. So different things that you can do here. So let's summarize this. Let's have the final summary. So normally what happens that beating occurs when two signals with similar frequencies continuously go in and out of phase. So what are the key points here? The two close frequencies normally when interact, right, then you will be having this phenomena. And the second is like amplitude, when rise and fall periodically, amplitude you can see that rise and fall periodically will be there. And the beating frequency normally equals to the difference between the two signals, we already discussed that. And it can normally create the fluctuating vibrations, or you can say the high vibration levels. And it can be, how it can be identified, it can be identified in the through the waveform and the spectrum. If you put your analyzer in the continuous mode, so you can see the waveforms or the spectrums going up and down, right? So now it's the question time. So I will be giving you two questions. The first one, what caused this beating in the vibration signals? So I am giving you three options, you can see to the screens. Please mention your correct answer in the comment section. And the second question will be, let's say that two machines running at, one is running at 25 hertz, another one is running at 24.5 hertz, then what will be the beating frequency? Again, three options there. Please mention your correct answer in the comment box. So overall, I hope you understand the beating, and now you can avoid the serious vibrations, such kind of serious vibration problem in your machines. In upcoming skill talk videos, we will continue explore more vibration phenomena used in the real machine diagnostics. Till then, take care. Have a nice weekend. Have a nice day. Bye.